Oh my god, it works! Let's go!
AI. If you've been on the internet at all over the past few years, you've heard of it. But can you tell me how they work? Or how they learn? As for me, I only had a vague idea. So I decided to make my own, from scratch, in C. This is how it went. So, I want this project to do a few things. I want it to use proper backpropagation calculus instead of autodiff, which TensorFlow and PyTorch, for instance, use. I want it to get comparable accuracy to TensorFlow on the MNIST dataset, which is the hello world of AI. And I want it to run at a fairly reasonable speed. So, with that out of the way, let's get started. Okay, so I've got a basic structure set up with the ability to create layers, create neurons within those layers, and to randomize the weights for those neurons. So if we just run this, we can see that it prints the layer with all its neurons, all the weights, which is great. And if we just run it again, we see the weights are different. So that all works. And now I'm going to add the ability to create networks, cost functions, and I think biases for the neurons, which I forgot in this round. So yeah, that's that. Okay, so I made all that. You still can't actually create a network or anything, but you have a network struct. I added all my cost functions, all the most common ones, and I added all the activation functions. All the most common ones are there as well. So now I'm just going to add some code to let it do some forward passes to make sure it works and to print the network so I can see what's going on. Okay, so that's all here now. And as you can see, if I just run it, it can calculate some outputs for this very basic network based on these inputs with its weights and stuff here. And it can also calculate the cost. And I've been using a spreadsheet that I made to check the calculations as well, in case you were interested in that. And now that that works, I think I can get some like very basic backpropagation working with the actual calculus with the help of 3 Blue 1 Brown, because I found an article of one of his videos on the website, and that should let me read it enough times and see if I can implement something basic. So I'll be back when I've figured something out. Okay, it's a little later, and I've got a very basic backpropagation algorithm working here, which only just works in one weight in the between the last in layer and the output layer. But if we run it, it should work. Yeah, so it calculates a derivative, calculates cost, and it does that. That was just on one run through. So if I increase that a bit, we can see that it does actually get closer to that number by minimizing the cost. So that works, and I just need to try and scale it to the rest of the weights and the biases. According to the article, it isn't that much more complex, but we'll see. Right, so I'm unsure if this is going to work when I scale the model up to more weights, more neurons in each layer, but I think I've got something for this kind of simple one-to-one-to-one network, which with these loops. So if we just run that here, like so, we can see that if we look here, it will train all the biases in the network and all the weights with the exception of this first one, because I just haven't implemented that yet. And so it does train them, and the cost does decrease. So that's good. It is sort of working. Now I just have to try a bigger network and see if my dodgy chaining derivatives code works. Okay, so I've been messing around with it, and it does seem to work on these kind of bigger networks, but I still haven't tested more than one output, so that'll be the next thing I test. But if I just run it real quick, as you can see, it does work, it does learn, it does approach that value I wanted it to approach, and if we just scroll up, you can see the cost getting better, and you can see that it's changing the weights. So yeah, the changes there. And so yeah, now we'll just test if if it works on multiple outputs, and we'll see if that works. I have a hunch it won't, because I'm not sure how my chaining is going to expand to that, but we'll see. As I expected, it wasn't correct, which was obvious as soon as I added multiple outputs. But I rewrote the whole backpropagation thing with the help of ChatGPT, which is some psycho-recursive stuff, and AI, writing an AI kind of thing. But the point is, if I run it, then it works, which is all that really matters, and I still understand what's going on here, which was kind of my whole point of doing this in the first place. So it's not like I just cheated with AI. I also added derivatives for the activations and the costs, which we needed for all of them. So if we just make it, and then we run it, as you can see, it does sort of approach these values that we wanted to. Right here. Then it doesn't get crazy close, because I can't make these add up to 1 for some reason, because if I do, then I get not a number errors, which you can see if we just do this, which I think, then I will occasionally get not a number errors, which is really weird. It doesn't happen all the time, so I can't figure out what's up with that totally, but I'll keep testing that and we'll see what works. And so once I fix that, all I've got to do is make a system that can read in the MNIST files and load them into a format that the network can run off just from this load input data file, not file, function. And then it should work. I'll be back once I've done that. Okay, I think it finally works. So it reads MNIST from this folder, and then it one-hot encodes the result vectors so that they can work with my cross-entropy cost function. And then it also batches the training sets here. And also, I finally wrote a training function, which just runs the batches from the functions to batch them, and backpropagates. And then it tests it on all the validation data. And so now, if we run it, and we time its execution, and we just give it a sec, and another sec. I'll be back when this is done. Oh my god. Okay, so it's finally done. It takes 4 minutes and 41 seconds and gives a 95% accuracy on testing. I'm not really sure why the losses are negative. I don't think it matters that much because it is actually training, but I'll have to keep an eye on that. So now let's just compare it against TensorFlow. Let's see how that works. I just copied the TensorFlow code from the tutorial to run on the same data set with the same settings as my model. And if we just run it real quick, it takes, give it a sec. Yeah, it takes like just 13 seconds, which is only like 23 times quicker than mine. And also, it is like 2.5% more accurate. I'm going to sleep. I can't do this anymore. Okay, hello. It's me again, the next morning, which is like 3 seconds for you. But anyway, I had an epiphany in a dream, and I remembered the GCC has optimization arguments. So let's try -03 and see how long that takes. And that already looks a lot quicker, but I'll time-lapse this. Still. It's still going to take ages. Okay, so that took 48 seconds, so I'm now only like 4 times slower. And I still haven't done any multi-threading or anything, which is awesome. And the accuracy is still close enough, so I think the accuracy is just due to the random initialization of the weights being off. That's what it seems like from my other tests earlier. So I know that -0 fast exists, but I'm not completely sure if the inaccuracies would just totally break the network. So just in case you don't know, O fast essentially says I don't care about accuracy in floating point operations, just make them as fast as possible. So let's test that. No, wait. Like so. And let's see how long that takes. Oh, that's speedy. That's really speedy. The losses are still negative, which I'm not totally convinced about, but it doesn't seem like it's having many effects on the accuracy overall, which is good. That's a big accuracy jump. But yeah, I almost feel like the inaccuracies might help it get out of local minima. maybe? But yeah, 95% accuracy, and it takes like 25 seconds. So it's still decent accuracy compared to what I used to have, and it's only 2 times slower than TensorFlow now, which is incredible. So there's no multi-threading, there's no GPU support, and it's a fairly basic approach. So for the moment, I think I'm satisfied with that. Let me know in the comments if you want to make a part 2, try and add multi-threading, GPU support, maybe try and improve the accuracy. But for now, I've had enough C, so peace out.